Welcome back, everyone, to another Explainer. I am genuinely so excited to have you here today because we are looking at a topic that is absolutely essential for anyone running production infrastructure. Seriously, if you're an SRE, a platform engineer, or really anyone in DevOps, you know that having clear, reliable observability into your systems isn't just nice to have, it's the whole foundation of your daily operations. So today, we're breaking down the major architectural shifts in the Grafana Kubernetes Monitoring Helm Chart V4. We are going straight into how it fundamentally refines observability by stripping away all those heavy, fragile patterns we've been stuck with in the past.
Look, if you've been working with Kubernetes long enough, you know the exact pain I'm talking about here. You deploy a monitoring stack, and suddenly, you're fighting your own tooling. Are duplicate deployments springing up out of nowhere like weeds? Is memory bloat randomly dragging down your cluster nodes? Just recently, InfoQ published an observability checklist for SRE teams, and they made it super clear. Properly managing Prometheus and Grafana in cluster environments is mission critical. When your monitoring tools actually become the source of your instability, you've got a major problem. If you've experienced these frustrating head-banging operational headaches with previous versions of the Grafana chart, trust me, you are definitely not alone. Okay, let's dive into this. Here is our roadmap for today. First, we'll look at the flaws of version 3. Second, the key upgrades in version 4. Third, solving those alloy memory problems. Fourth, we'll compare cluster monitoring options. And finally, migrating to version 4. Starting with Section 1. The flaws of version 3 and those operational headaches.
To really appreciate the improvements in this new version, we kind of have to clearly understand the before state. We need to look at what SREs we're actually fighting against every single day. And the absolute biggest grievance for a lot of teams was that the chart basically had zero awareness of existing cluster services. Think about it. Imagine you already have Node Explorer running perfectly fine in your cluster. You go to deploy the V3 monitoring chart, and suddenly, boom, duplicate deployments appear completely without warning. The chart just blindly assumed it needed to deploy everything from scratch. For teams trying to keep their environments lean and carefully managed, these unexpected collisions created instant operational debt and so much monitoring noise.
So, when we summarize the core systemic frustrations of V3, we see a really distinct pattern of overreach. You had those duplicate deployments we just talked about. You had massive unnecessary memory allocations, which, hold that thought, we'll get into shortly. You had incredibly overloaded configuration blocks where totally unrelated metrics were just crammed together, and under the hood, the whole shebang relied on these fragile list-based patterns that were literally a nightmare to maintain as your configuration scaled up. It was a system that functioned, sure, but man, it was brittle.
Moving on to Section 2. Key upgrades in version 4 and the shift to explicit control.
Now, what's really interesting about this upgrade is how it fundamentally shifts the chart's entire philosophy. It goes from let's deploy everything to a mindset of explicit control. And the absolute hero of this new philosophy is a brand new key in V4 called telemetryServices. This single key changes the game by making service deployment an explicit, intentional step. Remember that Node Exporter issue we just talked about? Well, now teams that already have Node Exporter running can simply tell the Helm chart to skip the deployment entirely and just point the monitoring features right at their existing instance. As analysts Wall and Buchanan noted when looking at this update, this explicit approach means no more surprise deployments. You are finally back in the driver's seat. And that whole theme of explicit control, it completely extends right into the configuration files themselves. In version 3, the chart used this incredibly overloaded cluster metrics block. It was like a junk drawer. Inside this one giant block, you had to manage Kubernetes cluster metrics, Linux and Windows host metrics, energy metrics through Kepler, and cost metrics via OpenCost. If you just wanted to tweak a tiny setting for your server's host metrics, you had to dig through the exact same file governing your OpenCost setup. It was cluttered, it was risky, and it was pretty much a classic recipe for a late-night debugging session.
Version 4 elegantly fixes this by breaking the architecture down into modular components. That giant overloaded block, it's been completely reorganized into 3 clean, distinct features: cluster metrics, host metrics, and cost metrics. And honestly, here's the best part. Each of these features now gets its very own values file. This separation of concerns means each feature's configuration only exposes the options that are actually relevant to it. It's so much cleaner, it's significantly safer, and it's going to make version control reviews way easier for your entire team.
Let's look at Section 3, solving alloy memory problems, particularly around pod logs. Okay, if you were running log collection in V3, you definitely want to pay attention right here, because this might actually be the most critical operational fix in the whole update. Let's walk through the flawed pipeline logic that caused so much grief. In V3, the chart's approach to the pod log pipeline was, well, incredibly inefficient. First, it would grab every single Kubernetes pod label and annotation and just apply them all in bulk as log labels. Then, it would check a list you defined called labels to keep to filter them down. And finally, it would just discard the vast majority of those labels it had just collected. Think about what that means. Your Alloy instances, which is Grafana's telemetry collector agent, were being forced to allocate massive amounts of memory for potentially hundreds of labels, just to throw them in the trash a few milliseconds later. No wonder users were tracing direct memory crashes straight back to this exact behavior.
So, version 4 fixes this by entirely ripping out that labels to keep list. Pod labels and annotations are no longer applied in bulk. Period. Instead of that messy, collect everything and filter it later approach, V4 shifts to explicit label opt-ins. You just declare exactly which labels you actually want promoted right from the start. Alloy never allocates a single byte of memory for labels you don't care about, which completely eliminates that devastating memory spike.
The absolute crucial point here is just how incredibly simple this is now. According to the official Grafana documentation, adding a label to your log pipeline is now a one-line change. One line. You don't have to redefine some massive default list, and you don't have to worry about accidentally breaking a really fragile filtering chain. It's a single, predictable line of code. And let's be real, that is a rare and beautiful thing in the world of Kubernetes YAML files.
All right, Section 4, comparing cluster monitoring options across the ecosystem.
And this brilliantly illustrates a really important point. When we zoom out and look at the broader Kubernetes ecosystem, we have to remember that Grafana Kubernetes Monitoring Helm chart isn't the only game in town. For example, there's the incredibly popular kube-prometheus-stack, maintained by the Prometheus community, which takes a very different approach. It actually bundles Prometheus, Grafana, Alert Manager, Node Exporter, Kube State Metrics, and the Prometheus operator all into one massive install. It heavily relies on the Prometheus operator's custom resources, things like service monitors and Prometheus rules, giving you a highly declarative, self-hosted observability stack that is completely independent of Grafana Cloud. Now, the Grafana chart, on the other hand, is laser-targeted at teams who are sending telemetry directly to Grafana Cloud or a managed Grafana stack. It gives you those built-in profiles and cost metrics right out of the box. So neither one is universally better. They just serve related but very distinct use cases depending on whether you want to manage Cloud Focus or a fully self-hosted independent architecture.
Finally, Section 5, migrating to version 4 for a smooth transition.
Now, if you're sitting there currently on V3, don't panic. The transition path has been paved pretty nicely for you. You don't have to go and rewrite everything from scratch. Grafana Labs actually provided a dedicated migration tool that takes your existing version 3 values file and automatically spits out a version 4 compatible output. The tool just quietly handles all those structural conversions we've been talking about. It seamlessly converts those fragile lists into maps, and it automatically splits those overloaded features into their new modular files. Plus, if you check out the Kubernetes Monitoring Helm Chart repository, you're going to find that a huge number of examples, along with all the official documentation, have already been fully updated to reflect this new V4 format. And you don't just have to take my word for it. The community reaction has strongly validated this upgrade. KubeSimplify recently posted on LinkedIn explicitly noting that nearly every fragile pattern from V3 has been replaced. They specifically called out the shift from lists to maps and that brand new opt-in approach to pod log labels we discussed, highlighting them as providing immediate practical benefits. Even better, they confirmed that the dramatic memory reduction in Alloy was a direct result of these exact label changes. It is always so great to see real-world operational validation of these big architectural updates.
So we've seen how version 4 entirely removes the guesswork. It stops those surprise duplicate deployments dead in their tracks, it breaks down bloated configs into clean modular files, and it saves massive amounts of memory by replacing those dangerous bulk lists with explicit control. So I'm going to leave you with this question. With V4 replacing all these fragile patterns, is it time to audit your own cluster's observability stack? Are your current tools actually working for you, or are you secretly working around them every day? Take a hard look at your current Helm values and see where explicit control could literally save your team hours of late-night debugging. Thank you so much for joining me on this explainer. Keep learning, keep building, and I will see you on the next one.